Welcome to the Shika Serbu Motor channel. This channel provides easy-to-understand explanations of car mechanisms. A carburetor is a device that supplies an air-fuel mixture to the engine. They were commonly used until the 1980s. But they rapidly disappeared in the 1990s, mainly due to stricter emissions regulations. In this video, we will learn about the principles, types, and operation of carburetors. When the engine draws in air, the flowing air causes the pressure inside the intake manifold to drop. The carburetor draws out gasoline due to the reduced pressure and mixes it with air. The amount of gasoline drawn out changes depending on the volume and speed of the airflow. In principle, at high engine speeds, a larger volume of air passes through the carburetor, leading to more gasoline. And when the engine speed is low, the amount of gasoline decreases. In order to efficiently draw up gasoline, it's necessary to increase the speed of the airflow. If the volume of airflow remains the same, narrowing the passage causes the air to flow faster. So in the carburetor, the airflow near the gasoline outlet is restricted. This part is called the venturi. The carburetors are classified into two types, based on the venturi mechanism. Fixed venturi carburetors have a constant venturi diameter, while in variable venturi carburetors, a piston valve moves up and down to change the venturi diameter. The fixed venturi downdraft carburetor was the most commonly used type in passenger cars. Generally, a branched intake manifold is used with a one carburetor to distribute the air-fuel mixture to each cylinder. Gasoline sent from the fuel tank by the fuel pump is stored in the float chamber. The float chamber is equipped with a float and a needle valve, which control the amount of gasoline flowing into the float chamber and maintain a constant fuel level within it. If the fuel level is not constant, it will affect the air-fuel ratio, leading to poor engine operation. At the moment, the fuel level in the float chamber is at the specified value. The float rises and presses up the needle valve, closing the gasoline inlet and stopping the flow of gasoline. The fuel level will not rise any further. As the engine consumes gasoline and the fuel level drops, the float also descends, causing the needle valve to open and allowing gasoline to flow in. As the fuel level rises, the float also rises. So when the fuel level reaches the specified value, the needle valve closes, and the rise in fuel level stops. In this way, the float chamber maintains a constant fuel level and ensures a stable supply of gasoline. During normal engine operation, the gasoline in the float chamber is metered by the main jet and discharged from the main nozzle. The main jet is a perforated component designed to restrict the maximum amount of gasoline discharged from the main nozzle during normal operation. When the driver depresses the accelerator pedal, the throttle valve opens, increasing the amount of airflow and causing the pressure in the venturi section to drop. As a result, the amount of gasoline discharged increases and the engine speed rises. With this action, the driver controls the engine speed. When rapid acceleration is needed, the driver quickly and firmly depresses the accelerator pedal. When the engine speed remains constant, in other words, when the amount of intake air does not change but the airflow path widens, the pressure in the venturi section increases and the fuel discharge decreases. Even though a rich air-fuel mixture is needed during strong acceleration, if the mixture becomes too lean, the desired acceleration power cannot be achieved. To prevent this, many carburetors are equipped with an accelerator pump. The mechanism is very simple. The piston is pressed by the linkage that opens and closes the throttle valve, causing fuel to be injected. At high engine speeds, the intake air volume increases, the airflow speed rises, and the pressure in the venturi section drops significantly. At this point, The negative pressure in the venturi section lifts the power valve, supplying additional gasoline. This enriches the air-fuel mixture, increasing engine output at high engine speeds. Many downdraft fixed venturi carburetors are equipped with a primary barrel for low speeds, and a secondary barrel for high speeds. When the engine speed exceeds a certain point, the venturi vacuum activates the diaphragm, opening the secondary throttle valve, and supplying more air and gasoline to the engine. At low engine speeds, close the secondary throttle valve reduces the effective barrel diameter, increasing the intake air velocity, and allowing efficient gasoline delivery. At high engine speeds, opening the secondary throttle valve allows for the supply of sufficient air and gasoline. During idling, the throttle valve is fully closed, and air is drawn in through a small gap. Therefore, the pressure downstream of the throttle valve decreases, while the pressure in the venturi section, where little air flows, doesn't drop as much. The gasoline needed for idling is drawn out through the slow nozzle, located downstream of the throttle valve. The idling speed is adjusted using the idle screw and throttle stop screw. The idle screw adjusts the amount of gasoline by controlling the passage area, while the throttle stop screw adjusts the fully closed position of the throttle valve to regulate intake air. The balance of adjustments between the two screws was determined based on the experience of a skilled mechanic. Because the intake air temperature is low, and the vaporization of the drawn gasoline is insufficient, starting the engine in cold weather requires a particularly rich air-fuel mixture. The choke valve is installed at the top of the carburetor. By pulling the choke knob on the dashboard, the choke valve is closed, restricting the intake air. When the starter motor is operated, there is a significant drop in pressure in the venturi section, allowing gasoline to be discharged, not only from the slow nozzle but also from the main nozzle, resulting in a rich air-fuel mixture. The side draft carburetors, made famous by Solex and Weber, were used in sports models. A carburetor is designed for 2 cylinders. For a 4-cylinder engine, 2 carburetors are installed, and for a 6-cylinder engine, 3 carburetors are used. They are similar to 2-barrel downdraft carburetors, in that they feature a fixed venturi and a butterfly-type throttle valve. But they do not have mechanisms for low and high-speed operation. Since they were not designed with performance at low engine speeds in mind, these carburetors could easily provide high output, but lacked flexibility at low speeds. Additionally, they do not have a choke valve for starting, as it would create intake resistance. For starting, they are equipped with a fuel passage that is opened and closed by a lever. During cold starts, this passage is opened to create a rich air-fuel mixture. By simply removing the top cover, you can easily access the jets, making it convenient to adjust the air-fuel mixture settings by changing them. Furthermore, the venturi section is made up of separate components, allowing you to choose a different venturi diameter simply by replacing the parts. For this reason, they were only used in sports models equipped with high-output engines. However, they could not meet the increasingly strict emissions regulations, and disappeared by the 1970s. Variable venturi carburetors are systems that adjust the fuel supply by changing the diameter of the venturi. VM type stands for variable manifold, and it changes the venturi diameter by moving a piston valve up and down. A tapered needle is attached to the lower end of the piston valve, and as the piston valve moves up and down, it changes the fuel passage area. When the piston valve is in the fully closed position, the needle narrows the passage area, reducing the fuel supply. When it is in the fully open position, the passage area widens, increasing the fuel supply. While it has the advantage of providing quick engine response, it also has drawbacks. When the throttle is suddenly opened, the venturi diameter quickly widens, causing the intake air velocity to temporarily drop, which reduces the fuel supply and leads to engine hesitation. For this reason, careful throttle operation was required with this carburetor. They were used in motorcycles with small displacement engines and 2-stroke engines. The CV type stands for constant velocity and changes the venturi diameter by moving the piston valve up and down in response to pressure changes caused by the opening and closing of a butterfly throttle valve. The SU carburetor, manufactured by the Skinners Union Company in the UK, is well known. There is a vent at the lower end of the piston valve, allowing pressure from the barrel to act on the upper part of the piston valve as well. When the throttle valve opens, and the flow velocity increases, causing the pressure in the barrel to drop, the pressure above the piston valve also decreases, lifting the piston valve. As a result, the airflow velocity in the venturi section is always maintained at a constant level, giving it a characteristic that makes it less prone to hesitation, even when the accelerator pedal is pressed suddenly. To prevent the piston valve from reacting too sensitively to small pressure changes, it is equipped with an oil damper inside the piston valve. Although SU carburetors disappeared in the 1970s, other types of CV carburetors survived into the 1980s by incorporating various additional devices. However, all carburetor engines were unable to meet increasingly strict emission regulations and were replaced by electronic fuel injection systems in the 1990s. Nowadays, no passenger cars use carburetors. Therefore, today, carburetors exist only as museum exhibits or as objects of affection for enthusiasts. In motorcycles, carburetor engines were produced until recently, but in the not-too-distant future, they will likely end up in museums or the hands of enthusiasts. Thank you for watching. If you enjoyed this video, please consider subscribing to the channel. We'll see you in the next video.